All right, we're talking about solving addition and subtraction equations. And we're first going to talk about addition equations. Okay, equations from yesterday are also known as what? Raise your hand. Yes, ma'am.
Problems with equal sign?
Okay, yeah, equations have equal signs, but what other word do we use to describe an equation from yesterday? Yes, Bella? It's a sentence, right? A sentence. Sentences have verbs, and so do equations. It's that equal sign. Okay, an addition equation, hopefully not to confuse any of you, has an addition sign in it. I know, it's hard to believe, but that's just what we mean by addition equation. Why we have to identify as addition is because when we have an addition equation, we need to use the subtraction property of equality. Does anyone remember what addition and subtraction are to one another?
Opposites.
Okay, not necessarily opposites, but remember what we call those? Something operations.
Order.
Ooh. Inverse.
Inverted operations.
Yeah, inverse operations. So they undo each other. And that's the whole idea here with addition and subtraction. All right. Do you guys remember, it was last year, I think, where I had like two of you come up at a time and we had a balance beam and I had you guys carry a book and then the other one carry a book and we took away a book. Okay, we're doing that real quickly and I get to do a little like dance online. It's my new dance. Yeah, it's that cool. And you can go faster, you can go slower. Okay, but anyway, when you have a balance beam, guys, you know what a balance beam is? I think you use in science. When you have two equal sides, you have a balance beam that is what we call balanced. Make sense? When I add something to this side, what happens to my balance beam? Starts tilting that way. But if I add that same weight to the other side, what happens? It evens out, right? We get, again, a balanced equation, a balanced beam. That's what we're doing in this class. We're going to add the same thing to both sides, or we're going to, what do you think, what else are we going to do? Subtract the same thing for both sides. And that's what we're dealing with that subtraction property. Okay, here's the subtraction property. If A equals B, is that an equation? Okay, what kind of equation or what kind of sentence, Cole? Open. Why is it open, Sophie? So this is an open sentence, but why is it open? Okay, Mandy?
It has variables.
It has variables, yep. Is it true or false, Jake?
True.
So open sentences, can they be true or false?
Yes.
Ooh.
Kobe.
Annie, can this be true or false right now? No, we don't know because we don't know what A and B are, so we don't know if it's true or false. But it is open for interpretation. We'll see that. We'll actually get some practical examples. If I have a balanced equation, can I subtract the same thing from both sides? And the answer to that is yes, because of which property? Subtraction property of equality. All right, let's put it to use here. All right, here's your first problem. And I'm going to erase this part. That wasn't a part of it. There you go. 26 3/10 equals y plus 3 58/100. Okay, so we're already starting with decimal problems, but that's good because we need practice. And these are actually real numbers. Real life problems, real world problems have a lot of decimals and fractions. Man. Okay, is this an addition or subtraction equation?
Addition.
How do you know that? Addition. Okay, so there's a plus sign. That's an addition equation. And this is actually the way you technically see it. What is happening to the variable y? What's happening to the variable y on the right side? Yes, Chelsea? Okay, it's being added with 3.58. That's an addition equation. Guys, we haven't seen this yet this year. The word solve. What does that mean?
Get an answer?
But we've been getting answers on a lot of problems so far. So what does it mean to solve an equation? So you give me other words for other kinds of problems. Find out what y is. I want to know what y is. Didn't we do this yesterday, though? Do you guys remember the replacement sets? You had some problems had 2 numbers in the replacement set, and then what did those last 3 problems have?
5.
5. Okay, do I have a replacement set here, guys?
22.
No, do I have a replacement set? Is there any brace with numbers in it? No, it's implied that you have an infinite number of replacement set elements. Is that going to work well?
No.
Probably not. So there's got to be a more efficient way. We still need to come up with a solution set, but we have no replacement set. Bless you, yes. Okay, what's happening to y? We said it's being added with 3 and 5800ths. So what undoes the addition? This is where we're going to use our properties and all that. Subtraction. What should I subtract from both sides? Callie?
3 and 5800.
Oh, very nice. 3. Subtract 3 and 5800ths. If I subtract from the left side, I have to subtract from the right. Sorry, excuse me. And that was my right and your left and all that stuff. Okay, but anyway, from both sides we'll be safe. All right. What is on the right side? What is 3.58 minus 3.58?
0.
Okay, oh, thank you. It is not nothing. It is 0. You're like, what's the difference? 1, there's nothing there. 1, there's a 0 there. Is that a difference? Is Mr. A being kind of picky? Well, let's see here. Y plus 0 is what I'm left with. Now, does anyone know a little property that I can use so that I can just leave it as y? Do you remember that property? Ooh, who could think back in that page with all those properties? Sometimes you had to list it. It wasn't as common, but now it's every day. Jack. Identity property of addition. So can I just say it equals y? And that's, okay, there's a justification is what I'm trying to say. And therefore, yeah, it's y. Okay, but 26.3 minus 3 and 5800ths. What do you have to do when you're adding or subtracting decimals? You have to line up the decimals. So I think we can do it right here. Borrow if you need to. Positive or negative?
Positive.
So I'm going to write 22.72 equals y. Okay, did we solve the equation? Did we find out what y was? You know what the solution set is? 22.72. That's your solution set. What was your replacement set again? Every single number out there. Do you want to test it out like we did yesterday?
No.
How many of you, especially the last one, I think 22, how many of you, it took you kind of a long time? If you did it, it took you a while, right? You're like, oh, you got to the third one, you're like, oh, 2 more to go. And the last one, finally, I'm done. Do you really want to do that on these problems? No. Can you? Yes, you've shown me you can, but we're not going to do that. That's just mean, okay?
Why don't you just subtract if you know this?
What are you doing?
From what I did on here, I did it when put it up on the board. I still got the same answer, but I didn't do all like 3, 5, 8, and the rest.
So what you did right here, so you didn't do it from here?
Yeah.
You didn't keep it balanced. You took away from this side, so you did that. This is what you end up having.
But I still got the right answer.
But I'm like this now. It's not comfy. I want to be like that. That's comfy. Well, actually, it's not bad if you just keep doing it back and forth. It's a good stretch. Sorry. Sorry?
It's not like they're going to care for them.
Okay. Let's keep going here. I'll call this example 1. The other one you can call example 0, which is okay. So example number 1, negative 9 equals z minus 4 plus 16. And I like this problem because it's a good introduction or reintroduction back into how to combine these numbers together. So, do you notice that this problem is a little different from the one we just did? Okay, it has an extra number in there. So what I want to do in these problems, first step is really add like terms or combine like terms, however you want to put it, add like terms, combine like terms. Because then I can see that it's very simple. Okay, somebody tell me if it's an addition equation or a subtraction equation. Sophie?
Is it a subtraction equation? No, it's addition.
Wait. Oh. Is it both? Or is it neither?
It's both.
It's one of those. It's one of those.
Subtraction.
Okay. Right now, I have subtraction and addition going on with z. So it's like either addition and subtraction, or you're really technically adding, so it's an addition, or it's neither, because you can't have both. Okay, let's make this clear by adding on both. Let's add like terms on either side. Is there anything to add to -9 on this left side? No, we're done with that. But on the right side, go ahead and do that. I want to see what you get. You do it on your own. So I got -9 equals and then z whatever. I just want to see what you get. Kind of see what you remember from the past. I'm going to get two answers here. One of them's wrong. Okay, what did you get, Max?
-9 equals z minus 20.
Okay, z minus 20. How many of you got z minus 20 on that right side? Okay, so a few of you. All right, did someone get something else? Chelsea?
I got -9 equals z less.
All right, now, can I state the obvious? Is -20 and +12 the same thing? No, so if I work out this equation, I'm probably not going to get the same as that equation. So I need somebody who's confident in their answer to explain why it's this one or that one, because it's not both. And we were pretty much split, which is what happened in the last class, which is cool. Braden, which one?
I think it's -9 equals z plus 12 because so there's subtraction and I want to do addition.
Oh.
So I changed the -4 to -4, which would make it z plus -4.
Okay, let me pause you there. Let me see if this is what you did. Instead of z minus 4, are you saying you did z plus -4?
Yeah.
Is that defendable? Is that justifiable? And if so, how? What do you call it? Think of this. Definition of subtraction. So is he allowed to do that? Okay. What's -4 plus 16? Positive 12. It's not this equation.
So I did this really funny.
Huh?
I got the same answer as if we would have getting -9 equals z plus 12.
I'm going to rewrite it up here.
I just, subtracted 16 from it, and then I added 4 to it, so I got the same answer. So
Wait, say that again. You did what? Oh, wow. I didn't want that. Oh, thank you. Okay, sorry. Say that again.
I subtracted 16 and then added 4 before I didn't add them together. She did it on the other side. She did.
Oh, did you?
The same answers you would have was putting the.
You got positive 12 or negative 12?
No, I'm saying, I did I subtract 16 from both sides.
Oh, I see. And then added 4 to both sides.
Yeah.
Yeah. You could technically do that. But you're going to see that if you can add like terms first, you're only doing something to both sides once, which is nice. Okay, but yeah, you could do that. Good question. All right, thank you. If this is the equation, is it addition or subtraction? By the way, guys, the other way, wasn't it a subtraction equation? Yeah. Now this way it's an addition equation. So what property are we going to use? The subtraction property of equality. But what am I going to subtract from both sides, Mandy? No. Sydney, what do I subtract from both sides? 12. You just take away 12 from here and from here to keep it balanced. What's z plus 12 minus 12? Z. Okay? And then here, you got to be careful. What's -9 minus 12? Isn't it the same thing as -9 plus -12, which is what? -21. Okay, if you did it the other way, where -9 equals z minus 20, you think you're getting the same answer? What do you think? Think you get the same answer?
No.
No? But, Ms. Ray, you did it this way. I did it the other way. Didn't we technically isn't it right? How do we justify which one is actually correct, though? Yeah, you just put in, so this is what I'm going to do. Ready, guys? I'm going to see if this is true or not, because if it's not, I'm going to change everything I just said previous to that. What's negative 21 minus 4? Negative 25 plus 16. So am I correct or not?
Yes.
Yeah, and it's no longer, I wonder if I'm correct. No, it has to be correct because that's the only number that fits. Okay, next one for you guys. See if you were paying attention. Oh my. Fractions. Oh, I know. Before I determine if it's addition subtraction, what do I think, or what do I do to make this a simpler problem? The first, add like terms. So I'm going to write that up here again. Add like terms. It just makes it easier. And you're going to see some of them are complicated, but if you just add like terms, it makes it a little bit more palatable to work out. Okay, let's see if any of you are paying attention. Obviously, on the right side, there's nothing to add or subtract. We just have one number. On the left side, what am I combining? Ooh. So hold on. What am I combining on the left side? Are there any like terms on the left side? Jack?
Is it negative 2 3/4 and positive 4?
Yes. Negative 2 3/4 and positive 4. We're adding those together. How do you add a negative and a positive? Same signs. Add, different signs, subtract. So I'm really subtracting these two, but which one is the bigger one? 4 minus 2 3/4. And then is my answer going to be positive or negative? Positive. Okay, so can anyone tell me what I do here? Because I'm kind of stumped. Chelsea, what do I do?
Can't you borrow from the 4?
Okay, make it a 3, and then... Yeah, whoa. Hold on, Chelsea. You're telling me that 3 4/4 is actually 4? That doesn't make sense to me. What's 3? 3. What's 4/4? What's 3 plus 1?
2.
That's all right. It's cool. It's late in the afternoon. Okay, can I do 4/4 minus 3/4? 1/4. 3 minus 2, 1. Positive. So I have M... Fill in the blank. No. Plus 1 1/4, which equals negative 1 1/2. Okay. What kind of equation is this, Laura? This one. What kind of equation is this? Addition or subtraction? Addition. How do I solve an addition equation? I use which property? Subtraction. So what do I subtract from both sides, Sophie?
Negative 1 1/2.
Okay, I'm going to say this very clearly. What do you subtract?
I'm used to it being
Yeah, it flips around, but yeah, get used to both ways.
positive 1 1/4.
Yeah, I'm going to subtract 1 1/4. Subtract 1 1/4. All right, what's 1 1/4 minus 1 1/4? 0. What's m plus 0? M. What property says that I could do that? M plus 0 equals m. Identity property of addition. Good. All right, and then we're just adding, what am I doing here? Okay, it's same signs and you're adding them, so you get, if you get a common denominator, this can become 2/4. What's negative 1 2/4 plus negative 1 1/4? Negative 2 3/4. And that's my answer. Man, that was a rough one there. How many of you kind of get this? Okay, how many of you can do one on your own? Of course you can. I see all those hands. Do this one. Just do this one on your own real quick. It's b plus 29 equals negative 29. If you can't see it, sorry, because there's a big glare. No glare. Partial glare. Oh, wait. Is it right here where there's no glare? I guess it depends on your perspective, too. Sorry.
I'm like right in between the glares.
That's why I can see it on swivel. It's right here between glares, and you're in the right spot. And then if I bring it here, you guys are getting a glare. You no? Oh, now you are.
I am on the
Now it's a big glare. You still, yeah, because you guys are farther out.
I'm taller than us, right?
Okay, sorry, just testing things out. All right.
How low can it go?
Well, how low? Where's the stick? I'm ready, guys. Oh, how low?
Right here, boy.
I'm so sorry. I thought you meant me. Okay, it could go that low.
And you're taller than us.
So it's like 5'10".
Just kidding.
Okay, Elizabeth, what kind of equation is this?
Hold up.
What kind of equation? It's an addition equation. Bella, what do I subtract from both sides? Okay, I'm going to subtract 29 from both sides. B plus 29 minus 29 is B. And then what's negative 29 minus 29? Negative 58, not 0. Or positive 58. All right, we're almost done here. Yes, ma'am?
Wouldn't it be positive 58?
Two negatives make a positive when you are multiplying. Oh, that's Monday.
What?
All right, write this down real quick. We're almost done.
Spoiler.
Yeah, spoiler alert. You have multiplication division on Monday. And I will see you on Monday.
What really?
Unless I see you at the grocery store.
If school gets canceled, then no.
Yeah. Good luck with that.
The retreat should get canceled because we're getting right on Sunday and Monday, right?
Oh, yeah, the retreat. I'm not sure how that affects.
They just canceled our last year.
Oh, actually, thank you for bringing that up. Guys, we have to do snacks for the retreat. So we have to bring crackers, cookies, prepackaged items. No, marshmallows, I don't know about that, but for my home base, well, that's one big package. Oh, I think I erased it when I was going through it again. Yes, thank you. So please, can you guys bring that Monday and Tuesday? But you may not be here. Okay. Just bring it in whenever you can, because we've had retreats where we have like a lot of stuff, and you guys get to pick wherever you want. And then we've had retreats where it's like there's like nothing there. You can have. No, don't bring too much. And don't forget, it's pre-packaged. So if you're going to buy Oreos, don't buy the tray of all those Oreos, because then it just comes to the teacher committee, and we get to taste that. It's possible. It's possible. Josh?
Are we talking about like
So we can't bring Oreos?
No, yeah, so you buy them, you know the Oreos that come in like packs of 6? You buy a box of that. That's prepackaged. Yeah, because they're all packaged, but then you have little packets. How about that? Okay. Subtraction equations. That's just a little announcement to the retreat, which I'm looking forward to. But anyway, the subtraction equation, what property are we going to use on these? The addition, because addition and subtraction are what kind of operations?
Inverse operation.
Inverse. If A equals B, then I'm allowed to add C to both sides and keep it a balanced equation. That's what we're saying with that. Okay, so here, is this an addition or subtraction equation? Subtraction. So what do I do to both sides? What can you do to both sides? Add what?
A number.
6.37 to both sides. But please be careful when you do that. Yes, you will get W. But here it is not 1.4 plus 6.37. It's negative 1.4 plus 37. So Parker, how do you handle that right side?
On the right side, you add the 0 to the 4 so you can like do it properly. And you do 40 minus 37, so that's 3. And then do negative 1 plus 6, which is 5.
Do you keep it like this when you're subtracting?
You switch it around.
Got to flip it. Yep. Okay, so now I have this problem, and I get 7, borrow if I need to, 9, 5, 4. Okay, so I got 4.97. Positive or negative? Positive. 4 and 97 hundredths. Okay, so just be careful and remember the rules for same signs, different signs when adding. Okay. Next problem here is a tougher one. This will be the last normal equation we'll do, and then we have one word problem we'll go through. Oh my. Oops. Look at that problem. It's possible I did, yeah.
I think it should be 1 plus 2 equals 8, 4 minus 1.
Okay, do you notice on this problem it looks a little bit tough? Do you know why? Because you have fractions and decimals. So how can you handle it? You can make them all into fractions. You can make them all into decimals. Neither one is better than the other than your opinion. You could do it both all fractions, you can make it all decimals, but you do want to make them really all one to make it easier to work with. So I think making them decimals might be easier. Okay, I think most of you, some of you are like, Mr. A, I like fractions. Good, then go ahead and do fractions. Okay, what's negative 9 2/5 become as a decimal? Negative 9 and 4/10 plus 4 3/10 equals h minus 3 5/10. So now I made them all decimals. Okay, Annie, is this an addition or subtraction equation?
It's an addition.
It's both.
I think I'm still waiting for it. It's a subtraction. It's subtraction, actually. But you're like, wait, there's addition, but there's also subtraction. But do you remember what my first step, Josh, is? Very first step. You said it the last time. Add like terms. I'm going to have to add these two together first, then I'll make it super clear. All right, negative 9.4 plus 4.3. You're adding two numbers with opposite signs. So what are you actually doing? Subtracting. You're going to do 9.4 minus 4.3. 5.1 positive or negative? Negative. Negative 5 1/10 equals h minus 3 5/10. What kind of equation, Callie, is this? Subtraction. And what do you do to deal with a subtraction equation? You add to both sides. But what do you add to both sides? Ooh, so either this or that. That's okay. Look at the variable. What's subtracting? What is being subtracted from the variable? 3.5. So you're going to add that amount to both sides. And that'll cancel that out. Give me h. That I'll call that the call for more homework. So if you want to call for more homework, make the call. That's more homework. That's all the problems we're going to have. Okay. When I'm dealing with this, guys, it's negative 5.1 plus 3.5. So what am I doing with this problem right here? You're subtracting again. So it says 5.1 minus 3.5. Borrow if you need it. 1.6 positive or negative? Negative. Negative 1.6. And that's your h. Yes, ma'am. Okay, great question. What's this as a fractional answer? Negative 1 and 3/5. Because 6/10 is good, but it needs to be simplified. Good question. All right, last problem. On page 44, I need someone to read for me the word problem there, example number 2. Page 44, example number 2. Chelsea, read it nice and loudly.
Okay. The difference between the ages of two brothers is 6 years. If the younger brother is 12 years old, how old is the older brother?
Okay, now some of you are like, Mr. I got the answer. Boom, got it. And I'm thinking, okay, that's pretty good, but so can a 5th grader. What a 5th grader cannot do, or will struggle very much with, is writing that as an actual equation. So they're not even thinking algebra. They're just thinking, 12 plus 6 is 18. Got it, Mr. A. Great job. That's impressive. 2 or 3 years ago. This year, what's going to impress me is if you can actually write an equation, because later on, by the way, it gets tougher. How many brothers do we have in this problem? 2. One is older, one is younger. Is that okay? Is that true?
No, it's not okay.
Okay. So, which brother do we not know the age of? Like, they don't tell us explicitly, this is his age. Older. So you're going to give the older brother a variable. I'm going to call him B. B for brother. Do we know the younger brother's age? 12. So the younger brother's 12. Great. I need to use those two pieces of info, and where it says the difference between the two ages is 6 years, come up with an equation that I have to solve. These are not complicated. These are not like, whoa, you got to just make it straightforward equation, but you do need to make it an equation, and it has to be one we solve for. Cole.
B minus 6 equals 12.
The older brother minus 6 years is equal to the younger brother.
I did 12 minus 6.
Okay, so remember the B is the older brother. So if you did 12 minus 6, okay, 12 plus 6 equals B. That is an equation, but really you're not solving anything because you just have to simplify 12 plus 6. So this is going to be the more difficult thing, and I want you to get practice doing that. Write as an equation, and then make this simple. You add 6 to both sides, you get B equals 18. That's how old the older brother is. So if you can write it as that equation, that's good, and the answer obviously is good as well. Okay, so I need this on those problems. You have a few of those. Let me give you a heads up. On the word problems, always make the variable the thing you don't know. So what age did we not know? The age of the older brother. So you just give it a variable. Why did I not pick O? It looks like a 0 or something, maybe an A. I don't know. You remember this in your homework last night? Why did they pick this? What is this? L. Why didn't they just do that? That could be a 1, so it's confusing. They do cursive L. What about that? Let's do uppercase.
90-degree.
Okay, it could look like a right angle. It could look like even an inequality symbol if you're just tilted a little bit. This is going to be clear. It's just a variable.
Another number.
Such as?
I don't know. It's like
Okay.
A fish turns.
All right, here's your homework.
no.